For Unit 8, Day 2 Introduction, this is just a review of some radical rules. So if you have 6 times radical 5, it can just be written without the multiplication symbol. Sometimes it might be flipped around, so the 3 would go in front of the radical, like the 9 would go in front of the 5. But you just have to know that that means like 3 times the square root of 7 or 9 times the square root of 5. In this example, you can multiply the 6 and the 2 because they're not in the radical. And 5 times 3, because they are in the radical, can multiply to be 15. And 15 cannot be broken down. Well, it can be 3 and 5, but they can't break down any further. So 5 and 4 would be 20. And then inside we would get 6. 6 can break down to 2 and 3, but not any further. Here we've got 5 and 2, which is 10. 3 and 4, which is 12, but 12 can break down to 2 and 6, so you have a pair of 2's and a 3, so this gets replaced with 2 radical 3, and that is times 10 from here, so that would be 10 times 2 would be 20 radical 3, so that would be my solution. Here we'd have 3 times 7, which is 21, and 2 times 11, which is 22, but 22 can break down to 2 and 11, and that can't go any further, so that would be my answer. In I, we have 4 times 3, which is 12, 5 times 5 is 25, the square root of 25 is 5, so that's 12 times 5, which is 60. For J, you have 2 times 4 is 8. 9 times 9 is 81. The square root of 81 is 9. And 8 times 9 is 72. There's like a 1 here, so 1 times 2 is 2. 6 times 6 is 36. The square root of 36 is 6. And that means 2 times 6 is 12. And again, there's a 1 there, so 1 times 2 is 2. 4 times 4 is 16, and the square root of 16 is 4. 2 times 4 is 8. Number 2, simplifying radicals, part 1. To simplify the radical in lowest terms, the 14 and the 2 can reduce to 7, and that would just be 7 radical 5. Here, 21 and 9, we can reduce that by 3, so that would be 7, that would be 3. And so I would have 7 radical 11 over 3. In number 3, we can simplify the 18. We really can't do anything with the 4 and the 3, but the 18 can break down to 3 and 6, 2 and 3. So we have a pair of 3's and a 2 left over. So we would still keep the 4 and the 3, but instead of saying square root of 18, we would say times 3 radical 2. And then that would be 12 radical 2 over 3, but 12 divided by 3 is 4, and so my answer is 4 radical 2. In part B, 2/8 could become 1/4, and 40 can definitely break down to 4 and 10. So 2 and 2, 2 and 5. So we don't really need the 1. We could replace the whole numerator with 2 radical 10 over 4, but that would become 1/2. And so we would have the square root of 10 over 2. Again, that 1, we don't really need it. It's just invisible in front of the square root. Okay, number 4, for rationalizing the denominator, this is when you have to multiply by the denominator. So the bottom is the square root of 2. So I'm going to multiply the top by square root of 2 and the bottom by square root of 2. This gives me 8 radical 2, And 2 times 2 is the square root of 4. But the square root of 4 becomes 2. And 8 divided by 2 is 4. So this is 4 radical 2. On part B, we would multiply by the denominator of radical 5. And you know to do this because you can't have a radical in the denominator. So all of these examples, we have to get that radical out of there. So I have I have 20 radical 5. And then 5 times 5 is the square root of 25. So this becomes 5. Twenty divided by 5 is 4, and that is 4 radical 5. And then lastly, for letter C, we multiply it by 3, and we have 17 radical 3 over the square root of 3 times 3 is 9, and that can simplify to 3. And 17 and 3 cannot reduce. Square root of 3 and 3 are not like terms, so we can't really do anything with that. So this is my final answer.